The WADC affects aircraft in Operation Red Wing, Projects 5.1 through 5.6. The first WAD took a toll on 12 March 1956 when the B-52 and B-47. The B-52 departed Seattle, Washington, making one stop at Hickam Air Force Base, Hawaii. The B-47 departed WADC and made stops at Travis and Hickam Air Force bases. Each of the effects aircraft had been instrumented by contractor personnel beginning more than a year prior to departure for the Pacific Proving Grounds. The arrival of the effects aircraft was delayed since neither fuel nor refueling facilities were available at Eniwetok until 12 March. The B-66 arrived on 16 March. This aircraft used a KB-29P tanker for in-flight refueling to accomplish the Travis to Hickam and Hickam to Eniwetok portions of the ferry mission. The B-57 arrived on 19 March, departing from WADC and having stops at Travis, Hickam, Johnson, and Kwajalein Islands. The aircraft used a Bombay fuel tank for the flight. This tank was removed at the test site, and the instrumentation recorders and controls were reinstalled in the Bombay section. The fighter aircraft were flown to McClellan Air Force Base, California, where they were cocooned for overseas transport. The aircraft were barged from McClellan to Alameda Naval Air Station, Oakland, California, and loaded aboard ship for transport to Eniwetok. The two F-84Fs arrived on 23 March aboard the carrier Battlewing Strait. The F-101 arrived on 10 April aboard the seaplane tender USS Curtis. With the arrival of the F-101, all the WADC effects aircraft were assigned permanent parking positions near the laboratory building. The maintenance and technical personnel readied the aircraft for participation in the operation and began the perpetual task of aircraft and instrumentation maintenance. Maintenance of the aircraft was performed by WADC civilian ground crews. Their work was difficult for several reasons. First, due to the lack of storage space, only minimum spares were stocked at the test site. This necessitated the frequent use of extended supply lines. Second, conflicts existed between the work schedules of the instrumentation and aircraft maintenance crews. As a result, one or the other were delayed. Third, practice missions and full-scale dry runs interrupted the preparation for the actual test. And fourth, the aircraft were maintained in a constant inspection status since lengthy downtimes for intermediate periodic inspections were not feasible. Instrumentation maintenance was equally affected by these same problems. A constant effort was required to keep the effects of excessive moisture and corrosion to a minimum. The work on the photo panel in the F-101 nose illustrates the complexity of most of the instrumentation. Photo panels such as this recorded many of the flight instruments and much additional data which did not require the response characteristics of oscillographs. Each of the 4 bomber aircraft had a rear fuselage installation containing radiometers and calorimeters and N9 gun sight aiming point cameras filtered to photograph the various spectral ranges of the fireball. Bombers having rear gun turrets utilized this mechanism for the installation. The instrument mount was preset at an angle which resulted in direct aiming of the instruments at the burst at time 0. These calorimeters and radiometers measured the amount and rate of changes of the thermal energy received at the aircraft. Since many size weapons were tested in Red Wing, the sensitivity of the instrumentation was changed between tests. These, as well as the basic structural instrumentation, required regular calibration and electrical checks. This recording center on the B-57 contained all the necessary recorders, balance panels, and junction boxes. The ground crews were not only busy preparing for each of the tests, but were also required to keep the aircraft flyable for practice missions and full-scale dry runs. The flight and instrumentation requirements often necessitated rapid and efficient maintenance in time periods much shorter than normally allowed. Special calibrations such as those in progress here were applied to elevators, stabilizers, and many other structural and control items to assure accuracy of the data. Positioning of all aircraft at an assigned point in space at time zero was desired to accuracies of plus or minus 250 feet in horizontal range and plus or minus 50 feet in altitude. The ground-controlled Radis navigation system was used for positioning the F-101, the F-84Fs, and the B-57 at Bikini. The installation consisted of HF and FM relay stations on 4 Bikini Atoll islands and 1 at Eniwetok Island. Reference stations were located at Wotho Atoll. These stations also provided accurate after-the-fact tracking data of all of the effects aircraft. The control point for the Radis system was located aboard the CVE Batowing Strait. All signals were collected at this master station, and the necessary receiving antennas were mounted on the carrier deck near the trailers which housed the recording and computing equipment. The 4 WADC aircraft positioned by Radis at Bikini used the MSQ-1A close support radar systems for positioning at Eniwetok. Each of the 4 MSQ-1A systems consisted of 3 mobile vans. Practice flights with each of the positioning systems were flown during the pre-shot preparations. The MSQ system was calibrated by visual alignment of the antennas with known reflective points and through helicopter flights over the intended test burst points. In order to have minimum local interference, the MSQ vans were located along the lagoon seawall, and flight patterns were established to keep the aircraft in the area extending in the direction of the lagoon. By the middle of April, office buildings and instrumentation shops surround the ramp area. Each day is crowded with aircraft instrumentation maintenance, proficiency flights for air crews, or full-scale dry runs for the actual test. Repeated practice flights were required to ensure accurate positioning. This was necessary since many aircraft would be in the immediate area of the test at detonation time, and protective thermal curtains would cover the aircraft canopies, obscuring outside vision. D-Day, the day everyone has been anxiously awaiting. The B-52 is the first of the effects aircraft to take off. Mission briefings were conducted to assign radio frequencies, abort procedures were discussed, and the latest weather information provided the crews. Although all but 2 of the shots in the test series were fired just before sunrise, the scenes here show a typical mission flown during the day. As the B-47 takes off, a dense layer of black smoke is left on the runway when the water alcohol injection system is used for takeoff assistance. The B-66 is ready and starting its takeoff roll. As the aircraft passes the camera, the assisted takeoff units are fired. Since the runway at Eniwetok is only 6,850 feet long, the B-66 used from 6 to 12 ATO units for takeoff, the total number of units depending on the gross weight of the airplane. The technical and maintenance crews have worked many hours following stringent time schedules to ensure proper operation of the aircraft and the instrumentation recording systems. Each aircraft had a definite time to perform each portion of the flight. Engines were to be started at the precise moment, and the aircraft had to taxi at the proper time to be in position for run-up and takeoff. One mistake here, and the schedule for all participating aircraft could be affected. Power carts are disconnected. Brakes are released, and the aircraft taxied to its assigned position. Taxi time for the F-101 and a short sudden rain shower crosses the field. These frequent rain showers and resultant water puddles on the runway were a constant problem. During the showers, it was possible for water to seep into the instrumentation system, causing some unbalancing of the sensitive pickup circuits. Water puddles on the runway would create sudden drag on the aircraft during takeoff and were potential slick spots on landing. As can be seen, the F-101 becomes obscured from view when water is sprayed out by the passing of the aircraft. All aircraft are airborne and approaching their orbit positions. The B-52, the B-47, and the B-66 used airborne radar navigation and bombing systems, often called K systems, for positioning at both Bikini and Eniwetok atolls. These aircraft took off several hours prior to shot time and flew racetrack patterns in the detonation area to determine wind conditions at altitude and to ensure accurate timing on the final run. For the shots at Bikini, the aircraft using radist equipment for positioning were vectored to an IP by MSQ radar controllers. At this point, radist took control of the aircraft and directed them to their time zero positions. A few seconds before detonation and all the aircraft are approaching their time zero positions. Thermal curtains are closed and instrumentation recorders turned on. Everything is ready. The circular white area seen here is the shock wave as it moves out from the detonation over the water. As soon as the fireball dies down sufficiently, the thermal curtains are opened. However, the pilots maintain their courses until the arrival of the shock wave and then turn for home. Another mission completed. As the aircraft return and land, the maintenance and instrumentation crews anxiously await their aircraft. Thoughts immediately turn to the instrumentation records with the hope that the required data was collected. All of the work and the waiting before the mission now begins to seem worthwhile. Even as the aircraft land, preparations are being made for the next scheduled shot, since it may be on the following day or even later on the same day. Immediately upon landing, RadSafe monitors check each aircraft for radioactivity as air police rope off the aircraft area. Technical personnel meet the air crews and debriefing begins. Each comment and observation by the air crews concerning aircraft performance or unusual phenomena observed may be of paramount importance to the technical personnel. Selected technical personnel move inside the roped-off area to inspect the aircraft. Simultaneously, instrumentation personnel record post-flight calibrations before removing the records for processing. The visible effects of the detonation on the aircraft are noted and photographed. These effects are an aid in determining the weapon delivery capability of the aircraft. Each completed mission means another cloud painted on the nose of the individual aircraft. On the 6th of June, Secretary of Defense Charles E. Wilson and other high-ranking official observers visited the test site. The WADC effects aircraft participated in a flyby in their honor. A great number of personnel from WADC participated in the effects aircraft program in Operation Red Wing. Their efforts and contributions have assured the successful accomplishment of our mission.